So last week, we talked about the requirements document. It started with the design document. Yeah. So we started. Oh, hang on. Yeah, it did. So last week when we started going through the requirements document, right? We saw it, what are the functional, non-functional requirements. We did the 3C and T to understand it when a requirement is correct, complete, and what is the third C? The 3C, right? One is correct, second one is complete. What is the third C? Consistent, right? And it's a testable. Then we looked into the requirements in the design document to say it's how the system is getting planned to build it, right? So we talked about what is the data design it's going to be. You saw it, all the data fields getting populated into the design document, right? We talked about what are the human interfaces, in other words, what the screenshot will look like it, what are the page layout is going to be, how the interaction happens, right? From a one page to another page when somebody logs in, what exactly they'll look into it, right? We talked about the external interfaces, the email flow that it goes into the system. Now that we have an understanding of what exactly happens in the requirements phase and in the analysis phase, let's look into a little bit around the software testing. So when we talk about testing, we're going to talk about a whole bunch of things, but the most important thing is we'll talk through the various testing terms and the test documents. Okay. So what is the reason, why do you do testing, right? The whole purpose of testing is not to pass it, but to identify the defects, right? So see it, whether we can fail the systems or not, right? So it's an intent of finding an error by doing some activity is essentially a software test. Okay. And the side effect of it is if you don't find any errors, right? That means the system is behaving as expected, right? So the whole purpose is the system fit for purpose, which is essentially whatever your business partner asked. Hey, we want such a system. Is system ready and fit to do that, right? Now, when you do the tests, right, all the tests is going to be broken down into different scenarios and test cases. So what is the characteristics of a good test case? Okay, a good test case is essentially something that gives you a higher probability of finding an error. Okay. Another aspect is a good test case is it gives you ability to check or find an error in a new area, right? So it should not be a redundant. Okay. And then as we write the test cases, you will see there are certain things you want to do it. You don't want to make it too simple. At the same time, you don't want to make it too complex. And we'll walk through it, the reasons why you don't want to do those things. Okay, when we start writing test cases early next week. Okay. Now, as a software tester, right? I'm calling a tester and not a quality assurance person, right? Because you're wearing a tester's head at this point, right? Your purpose is to find the error as early as possible. Okay, so that it can be fixed. Okay. When you look into overall applications, right, there is only two individuals or two roles which has a very good end-to-end understanding of any system. Okay, one is architect, who essentially builds it how the system is going to do it, and the second person is a quality assurance or a tester, right? Because they are looking at to test and find the error in all the areas into it. Okay, so that's an important role that comes into it, because when you look into a larger systems, you may have 10 developers and just 1 or 2 testers into working in a team, right? The developers are good at knowing what they build it. The tester is going to go look at across the entire thing. Okay, so that's where you come into play, is you understand the whole. The reason why we ask you to read the requirements document into it, so that you understand the entire picture. So that when you're testing it, you can figure it out. Hey, what if I do this? How it is impacting the other thing. Okay, the whole purpose, you want to uncover the hidden bugs. Remember, we talked about it's much more easier if somebody builds a monolithic application to do that, right? End user is going to think it from a functional point of view, versus you're thinking it from both functional and non-functional point of view. Okay, and as the architecture has evolved it, right? Specifically, most of the times when you're going to interact into the world now, you're going to get into the web application, which is built at either multi-tier or the one that is going to also enable the user to access it over mobile and various other devices. Right. So as a tester, you need to make sure you're covering test scenarios. What if this goes down? What if that goes down? How does the system respond? Okay, that's the key thing as you go through it. The whole purpose is you want to make sure software is usable and reliable. Now let's talk about software testing lifecycle. Okay, do you guys remember the STLC?
Yeah.
We talked about, right? You start with the planning. Then what do you do? Analysis.
Then design.
Then design. Then implementation, testing, acceptance, and then maintenance, right? Same way, if you look into the test life cycle, it is kind of geared towards to work in conjunction with the STLC or software development lifecycle. Okay, so as the users are identifying the requirements, that's where you start getting engaged. Remember, we talked about you don't do much work in the planning phase. You start working with the analysis phase. When somebody has put the requirements document, that's when you get it. So the first thing you start doing it is you understand those requirements in STLC. As the business users are identifying requirements, you work with them to make sure it is complete, correct, consistent, and it's something that you can test it. Okay. Once you have the requirement, you go ahead and start identifying what is something known as acceptance criteria. In other words, if somebody builds that requirement into the system, what are the criteria you're going to use it to say, yes, I'm going to accept it, it is built in. Right? So if somebody puts a requirement that, hey, 90% of my pages should give back response within 2 seconds. That's a requirement, right? Your acceptance criteria is, I'm going to pull up that page, and 9 out of 10 times, it is showing it up in less than 2 seconds. Right? That's my acceptance criteria. Okay. So for every requirement, you start identifying, putting into test case, what are my expected results or acceptance criteria is going to look like. Okay. Then you go ahead and do it in strategy planning and design. This is where you go and say, okay, if I need to test that, what are the step-by-step instruction I'm going to follow? Okay, think around it. If you're cooking a meal, you're identifying what do you want for dinner, right? You put together, well, what does it look like when I'm done with cooking that meal, right? Then you say, what are my step-by-step recipes going to be? Then the execution is, I'm going to follow those step-by-step recipe. I'm going to make that, okay? While I'm making it, there may be some spices may not be right? So I'm checking it and I'm adjusting it, right? And then finally I'm testing it and saying, is it ready? If it's ready, I'm going to accept it. It says that my meal is done. Same way, I have requirements. I define what criteria I needed to do it, to test it. Then I identify what step-by-step instruction I'm going to do it in order to test that requirement. when system is available, I'll follow those step-by-step instructions to see it, whether it's working or not. If it doesn't work, I'm going to identify the defects. I'm going to give it to development team. They're going to fix that. They're going to give it back to me. I'm going to validate that the fix works as per this instructions for this acceptance criteria. If so, I'm good. I'm going to look at it. Did I look all of the test cases? Did everything pass? If it does, great. I'm going to accept it. Sometimes not everything may be passed, but I may decide that it is okay to have that bug in the system. And then once it's done, I baseline it and then starts back again when they want to add a new feature. Okay. So that's the normal cycle that you're going to see it for software development. Okay. There is another view that you can see it, something known as the VModel. Okay. So in this model, as you go through it, right, the first thing comes a user requirement. Right. So your requirements are defined. When the requirements are getting defined, remember I said you start building acceptance criteria, right? In this scenario, it is same thing as I'm going to build what is known as user acceptance testing. How do I know that this requirement is working from a user's viewpoint? Okay. Then the requirements is then taken it by a system design or architect person. It's broken down into different functions. So if you recall it in our flow, right, it was broken down into 8 or 9 functions into the functional decomposition, right? It's like manage user, manage dealers, manage lenders. All of that are nothing but the functions, right? So you take a big requirements document or a big picture, break it down into a small functional component of it. And as you break it into a component, you build it out something known as a system test. Okay. So requirements maps to the user acceptance test. Break it into function and says, I'm going to be able to test each of the individual functions. That becomes your system test. Is this function working? Is this function working? Is this function working? Then typically you take that function and further break it down into technical specification. If I have to implement, let's say, manage lender, what all things I need to do it? That's what the development team does. They just take that functional specification and break it into technical specification. Okay. In order to do this, I need to interact it, right? For example, let's say a lender approval and rejection, right? When they do it, when they approve it, well, it needs to go and interact with the email systems. Well, what data it's going to send it to email system? How it's going to pull up the information about who to send that email to, right? All of those things are technical specifications. And then in order to do that, then you go ahead and do something known as a link test. Okay. A lot of times this thing is also known as an integration test. Okay. So those are more or less kind of synonym, the link test or integration test. How do I go ahead and like it's going to take a component which has multiple pieces and test them together. Then you take it further one level down. Okay. This is where now individual developers are writing their code. It says, if I need to go and find it out the email address for that particular person who that notification needs to go and lender approves or rejects, this is the steps I'm going to perform in order to do that. Okay. That's sometimes its smallest piece. It's known as the unit level programming or program specification. And in order to do that, then you build something known as a unit test. Okay. If you go down this path, right, no code is written yet, right? They're just breaking it down, the big problem into smaller and smaller chunk. And then along the way, they're validating it, how I'm going to test all of the smaller chunks whether they're validated, working or not. Okay. Then you start implementing that. Okay. So you take those program specification, start writing the code for it, right? To convert into the computer language. Okay. And then once you're done, you say, it's okay, I'm done with the code. So remember the unit tests that they wrote it, that if I write this code, this is the way I'm going to validate it. They start executing it. Okay. If my individual component passes, then I'm going to go ahead and do the integration test. If that works, then I'm going to go ahead and do the system test. If the system test works, then I'm going to go ahead and give it to the user to do the acceptance testing. Okay. So this is another way to see it, the testing cycle. As the development team breaks it into small pieces, you write how each small piece is going to be validated. And once all of the pieces are implemented, you start execution of those test scenarios, right? So when we talk about here, right? So the downward slope of V, you're using it's all of the strategy planning and design. Okay. The upward slope is the execution. Okay. So this gives you more insight into how each one of those two circles get implemented.
So they are using the both model.
This one is a holistic over bigger picture,
Okay.
right? So think around it. You're playing a quality assurance role. You're going through the entire life cycle. Now, if you're wearing only the testing hat, right? This is how you operate when you are just looking at from a tester viewpoint. Right?
So the unit test and the integration test, right? So the developers will do that, right?
Yeah, we'll talk through it when we go through it and stuff, right? But I want you guys to think around it. This is how the testing occurs, right? And we'll talk in a moment like who performs all of those tests, right? But think around, this is the holistic picture. Okay, any questions? So in addition to the requirements document and the design document, when you're essentially building a system, so you also create something known as the test plan document. Okay. So this test plan document essentially outlines how the system is going to be tested. What all tasks it's going to be performed, what are the timelines. It also tells you what are the artifacts or the outputs you're going to produce it as a quality assurance or a testing team member along the way while the system is getting built. Okay. Typically, it creates by a person who is acting as a test lead on a project. So if it's a small project, right, and if there's only one tester, that person also plays the role of test lead. If it's a large project, right, involves hundreds of testers, sometimes you always have somebody known as test lead who is kind of responsible to coordinating and overseeing the entire testing effort. That's what the test lead is going to be. Okay. And the whole purpose of the test plan is to validate under what circumstances you're going to accept the product. Okay. So what does the test plan contain and look like? It starts talking about what is the overall scope. And here by scope, what they mean it is what all we're going to test it. There are certain things they may say it's not in our scope, we're not going to test it. But here are the other things that we're going to test it. They talk about the approach, how we're going to go about testing that. Okay. They also talk about how many people we will need, what kind of software licenses we'll need, what kind of machine and environment we will need it. All of them is lumped as a resources. Okay. In order to execute this test plan, what all resources I will need it. Then it also talks about the schedule. Okay. What time it's going to start, when it's going to end, how many weeks, months, whatever the timeline that they needed to do. It also, as part of schedule, also identifies when and what they're expecting. So remember, if you look into this thing, right? You can write as much tests as you wanted, but you cannot execute till this code thing happens, right? Till the developer implements. Think around it. If you're building a house, right? The county has all of the standards. They've defined it. Hey, if I need to test a plumbing system, these are the things I'm going to check it. If I need to test a electrical system, here are all the things that we're going to do, right? But they can't execute unless the house or the structure is built, right? That's what it is. Like once they build a structure, then you can start executing all of those things. Okay. So that's what the schedule talks about, is when I'm expecting that to be ready, when I can get started. In addition to that, it also talks about what are the test items, what features I'm going to test it, right? So as part of scope, it not only just gives the high level scope, but it starts breaking it down into a little bit detail. What are we going to test it? How are we going to do it? What are the tasks involved in order to do those testing? And in this scenario, it does not go as planned. How are we going to address it? So essentially, what is my contingency plan? And what are the risks? So you may lay out a perfect test plan, but if the software team does not deliver the code to you in a timely manner, right? And then your customer is still expecting the software system to be delivered on such and such date only, right? You can't just ramp up and says, hey, I'm going to hire 100 people to do this testing, right? You get to figure it out. What is the risk? What are the things that you can do it to essentially mitigate that? Also, sometimes you may have to say, we're going to slip the date of the project. Here is the reason why, right? And sometimes say you have to accept it a not fully tested system if you don't want to wait for that long, right? So all of those risks and contingency planning are outlined in there. It also talks about the tools. Remember I said, what are the software license or products you will need, what environments you will need it. It talks about those. And then talk about the deliverables. What are the metrics? What are the kind of reports that you're going to produce it during that to give an indication whether you are on track to deliver that product or finish testing on that particular product in the timely manner. Okay. It also talks about a lot of times the procedures, the standards and guidelines, what they're going to follow. Okay. In addition to that, it contains a lot of times detailed description around the scenarios and the test cases. Now think around scenarios is an overall hypothetical situation. Okay, that needs to be validated within the system for the function of the system. Okay. In example of our flow, right? You can say, hey, my scenario is I'm going to create a dealer in the system. That's my scenario. Now, there are multiple ways I can create the dealer, right? By providing all the information or providing only the required information. Things I could also test it is by not providing some of the required information and see how it behaves, right? So scenario is essentially a higher level construct that may involve your multiple test cases. And test cases is essentially a single thread within that you're trying to validate it. Okay. So test case is a condition under which you're going to try to test the software to see if it's working or not. Okay. For example, if you're creating a dealer, one of the requirement is it has to generate a unique franchise number. Right? What if I try to create a dealer without providing a state? Can I generate a franchise number? Can't, right? Because that's a requirement. So that's a condition that I'm going to try to do it is that what happens? How does system behave if I don't provide a state? In those scenarios, right? You say, hey, you know what? If I don't provide a state, I should not be able to create it because I can't create a unique franchise number. So in those scenarios, I should not allow a user to create the dealer. Or it should give them some sort of error message that please provide a state. Right? That's a specific test case, but it is still part of creating a dealer functionality or scenario. Okay. You understood the difference between those two? Higher level, specific one within that higher level.
So is that, the test scenario is like, I mean, what to test? Like that?
Test scenario is what kind of feature or capability you're testing. And within that, that capability, you may have multiple test cases or multiple things that you need to test it in order to complete that test scenario.
So with all this, that means that as a tester, you are there, you have an idea, or you are aware that the system is going, the software is going to be created, right?
Yeah, that's why you started with the requirements document, right?
Okay.
Because that's telling you what software is going to create it.
Okay.
So you can build the scenarios and build the test cases to say, if this is the software, how I'm going to test about it.
So you are aware ahead of time.
That's why I like it is that when you look into it, right? Like you start with here, and then you find the requirements and understanding that requirement. That's where everything starts. Okay. Then test plan also talks about the test scripts and then metrics. Right? There are two different types of metrics. One will be a product metrics and the other one is process metrics. Product metrics typically talks about the behavior and capabilities of the software. How many functions of software are working? How many functions I've tested, those kind of things. Process metrics talks around the overall testing process. How many test cases I can create on a daily basis, right? How many defects I'm finding it whenever I test this many scenarios, right? It's around the process. How effective is my process? Okay. Now, what exactly a test case contains, right? So it's very simple, right? Remember, like we talked about even in the, when you write the software program, right? It has, take some input, perform some processing and generates the output, right? So when you're writing the test case, right? What you need to do is what are my input, right? Then you also need a recipe. What are my steps I'm going to perform along with those inputs in the system? And then what are my expected results or behavior I'm expecting it? When I give those input, follow those steps, what should be the system producing? Okay, that's in a nutshell is a test case. Okay. A good test case, as we talked about, right? The whole purpose for you running testing is to find a defect, right? A good test case is where you have a very high probability of finding a defect. Okay. Another important characteristic of a good test case is it should provide you an unambiguous expected results. Okay. So, for example, let's say if I'm like it's testing the electrical system and I turn on the switch, I should exactly know what turning on that switch is going to give me a result, whether the light is turned on or not, right? But if I turn on that switch and I cannot say whether the light is turned on or off, I can't test it, right? So my test case scenario should be clear that it always produces a clear result, whether it's passed or failed, right? Whether it's a bug or not. But if I don't know whether it gives me the results or not, then there is no way it's not testable, right? The test case should be testable. Also, it is repeatable and predictable. By that means if I run in the same system by giving the same input, as long as the condition or state of the system is same, it should always produce exact same result. Okay, that's repeatability. Predictably, it should not only produce results, but also it produces the same results every time. Right, so if I turn on the switch, I know it will always turn on the light, and it only turns on the light. Okay, if I turn off, it always turns off. That's predictability. Okay, but if I turn on switch and sometimes it turns on, sometimes it turns off. That's not predictable, right?
So you mean by a repeatable test? So let's say you found a bug, you assign it to the developer, right? So they fix it, they assign it again to you to retest it, can use the same test, right?
Yes.
That's what you mean by repeat.
Sort of. But again, repeatable means I don't have to do anything else. I can use the same steps all the time. Repeatable. That's repeatable, right? And predictability is if I use the same steps and if the state of the system is same, it should give me the same results. Okay. Now, this is something that you always gonna run into as soon as you go into the world. Okay. There is no standards around testing. There are guidelines. Okay. There are standards around the templates that people use. But you can't just say, hey, if you're doing it a web-based applications, you should run this, this, and this. Part of the reason is no two softwares are same. If I go to, let's say, a Microsoft to take their productivity tools, right? Words, PowerPoint, and everything. And if I'm doing testing on those software, like, that's a one way. Google provides similar tools, similar capabilities, but it's completely different tools. Right? So I can't say, hey, I'm going to use this standards to test it if the Word document or Word software works appropriately or not. You can't take that and give it to the Google and say exactly everything works. Right? Because the nature of the systems are different every time, even you're trying to get the same functionality. Right? You cannot have the same standards. What you can do it is you can provide a guideline or guardrail. And that's what most of the places you're going to see is what is the standard processes you should use it in order to test it. But your test cases are not always going to be exact same. It's going to be different from a different system. Okay. That's why you're going to see it is there are no industry-wide test standards. Okay. But like for example, if you're trying to do a manufacturing, right? Manufacturing has a lot of standards around it because it's exact same thing you're going to produce over and over again. That's not the scenario, right? If somebody writes a web application, it's not exact same over and over again. Versus somebody builds a car, it's exact same over and over again. So you can implement standards there. You cannot implement standards when there are variations. Okay. So all you can do it is focus on what are my processes, what documentation I need to create it, right? And what are the techniques I'm going to do it. Now, let's talk about the environments. As you go into the test plan, it talks around the environment. Okay. At a high level, within the software development lifecycle, what you're going to see is a development environment where your software developers are like it's constantly building and constructing things. Then you're going to have a test environment, which is going to be a little bit more stable than the development environment. By stable means nobody's changing it every minute. If you go into the development environment, things are getting changed every minute because developers are writing a code, checking it. Oh, it's not working. Let me go fix it. Let me go fix it type of thing constantly. Okay. Once they feel it's ready to be tested, once it said, hey, I'm done with this, then they give it to tester. Take an example, right? And I don't know if you observed it. When a house gets built, right? The constructor, right? Whoever the builder is, they're going to constantly build it, right? So they may just start putting the frame, the wood didn't came out proper, so they're going to break that. put the new wood into that particular frame, fix that, right? They're constantly changing, they're building small pieces, but it's not ready for the inspector to come and say, is the frame working as expected? Is the frame solid or not? Right? Once they are done building the frame, then they will say, it's okay, inspector, come and inspect it now. Right? Inspector can't inspect it if the frame is still in the process of building or constantly changing. Right? Because it's useless for them. Even if they pass it and if it's changing it, they have to come back and check it again. Think around the same way, right? The software is getting built, the developer is constantly building it, breaking it, changing it, right? So for a tester, it's not a value because that thing is changing. Whatever I test today may not work by the time you fix it with something else. So I want some sort of stability that where it says, yes, it is working and I'm not going to change this much now. At that point, you can get involved and get tested. Right?
So they need
Yes, sir.
product are ready to test it.
Right. So they're gonna flag it that, hey, this particular function, for example, right? They may just say, hey, I'm gonna build a module that is gonna allow you to manage the dealers. While they're building it, you can't test much, but once that particular functionality is done, they can say, okay, this functionality is working, you can go test it while I go ahead and build the manage lender functionality. Right? Because it's not constantly changing dealer at that time, you're just changing with the lenders. Get yours.
Yeah, so, as a tester, once the, software is building, and you have to, what are you doing, you just taking the regulation? Or writing the scenario?
So that's where it comes in scenario, right? So that's what things that happen, Sparrow, right? The user, the development team got the requirements,
Yes.
they're gonna start building it. While they are building it, you're gonna take it requirements and you're gonna build all of the test cases and test scenarios and test steps, right? Once they give you software, then you can execute that instruction. There's no point for you to wait until they're done and then says, now let me write the test cases,
Yes.
right? That's something that you can do it in parallel. Okay,
But aren't the testers and QA different? The testing process, like it starts a little later after the development starts.
so again, remember,
So,
tester, a lot of times, it's just a hat that you're wearing as a quality assurance person.
Mhm.
So while the requirements are done, you're not testing anything yet, right? But once the requirement's done, what is the first testing I ask you guys to do it? 3C and a T, right? So even though you're a quality assurance person, you started testing things. You started making sure, is the picture complete? If the picture is not complete, you're raising those flags by saying, hey, it's not complete, it's not correct, it's not consistent. Right? You're testing because let's say if you didn't do that and a developer started building it, they will build something that is not clear by users that this is what I wanted, right? Take an example, right? And a lot of you can relate, right? The kids comes and says, I want to eat something for the dinner, right? What does that mean? Right? Do you want a dinner? Do you want a snack? What exactly you want? So you start asking, what do you want? Right? That's the testing process, right? The user came and says, I want this. You don't understand it. You start asking it, right? That's a testing. Making sure you're building what they want to eat. Right? That same scenario goes in the software. The user will say, I want certain things. Sometimes they will be very clear, right? Sometimes kids will come and says, I want a breakfast and I want a milk and cereal in the breakfast. Very clear, right? Users will do the same thing. I want these things and here is what it should do. Good, clear, then you allow it and go ahead and do that.
So that the user is using the user stories, what they to use the requirements.
Yeah, the user is the one, or like it's right in this scenario, right? You may have a business analyst who work with the users. But at the end of the day, it's the user who are specifying what they want because they are the one who are writing the check for that work, right? Think around, you're building a house. Who is writing the check? You are writing the check. Do you want the builder to define what do you want in the house?
No.
You don't, right? Same way, if I'm paying for it, a certain software. I want to define what I wanted because I have the business processes, which this software is going to support it.
So is the users, are they the same as the stakeholders?
Not always,
Okay, no.
right? Stakeholders, people who have vested interest. They might be writing the check, but you may still have for example, the dealers might be signing a contract, but it's dealer employees who are you going to use the system. So they will help you to define the requirements. Right? So the sandbox or the development environment is always constantly changing, right? So it doesn't make sense for you as a tester to test it. There. So when occasionally they said, hey, I'm done with that functionality, it's ready for test. They will give it to you. And the way they give it to you is they have their own environment, their own servers, their own accessibility URL and all of those things. When they give it, it's here is the software. And then there will be a test environment. Remember I say this, in the test plan, it identifies all the resources I needed. It says, here is the machine or which will install the software where you will go and run the test. So they give you software, you install it, and then you test in that test environment. Right. And depending on the type of activities you're doing it, there may be a system test, right? What we talked about. There may be integration or link test. Then there could be also what we a lot of times knows as end-to-end testing. Right. So entire system is built. That system may be interacting with the other. So if I'm building it, an e-commerce system, right? I'll have a payment, I will have product, and I have shipment, right? All of those has to work together end to end in order for fulfilling a provision order. Right. So I'll perform that end-to-end testing. Then there will be a loaded performance testing. So essentially, yes, the system works when one user is logged in. What if 5,000 user logs in and perform the similar task? Does the system still give the response time in a reasonable manner? Right? That's what the purpose of that. Think around, right? On Black Friday, you try to go to some popular e-commerce's website, right? It slows down. Right? Think around a major event, a concert, right? Live streaming. It works fine as long as 100,000 people logs in and try to watch that at the same time. But if 2 million people logs in and tries to do it, right? Does it still work? Does it still give you a response time in a manner? Or you constantly get that buffering sign, right? Then it's not usable, right? So the purpose of the loaded performance testing is allows you to do those kind of testing. So that is also going to be done in the test environment. And then the user acceptance testing that we talked about, right? After everything is working, you're going to have user log into the system and says, yes, it is working the way I expected. Okay. And once all of that works, then you said, okay, now the system is ready to use. So they go ahead and put it into production environment, which will be another set of servers. That's where they migrated. That's where things are. Okay. Now, as a testing, right, you want to stay within this environment only. Okay. Occasionally they said, hey, you know what? We don't have all the data. Why don't you perform that testing in the production? There's always risk associated with it because these are the live data. So sometimes you can do some sort of what we call as non-destructive testing. In other words, it doesn't change any of the data. You can do a read-only, those kind of testing, it's fine. Anything which is a destructive, you should never do in production. Okay. At the same time, the developer may say, hey, you know what? It's not completely ready. It's working in my environment. Can you come and test it here? Occasionally it is okay to do some sort of testing, but remember, they're still changing it. So there's no guarantee what they worked on it is what will work here and what will work here. So as a test team, right, when you're building a test plan, make sure you identify everything that what you needed in a test environment. So that allows you to build and execute test in a much more precise way.
Is it possible to say again, like the system integration testing, like given like a accurate examples for this?
So we'll talk through it as we go through it, right? System test. The intention is, depending on the size of the project, right? You may have a different system test environment, different integration environment, different load and performance environment. Or if it's not a very big project or you have resource constraint, you will do all of those things in the same environment, but a lot of times you time slice it. It says, hey, you know what? Your load and performance test, you will do it only in the night from 10 to 12. Right. You may just say it's user acceptance testing. When they are performing it, we are not going to do any more load and performance. This 2 or 3 days is reserved for the user acceptance testing. You can do those kind of things, but it's still a dedicated environment if you think around it. Okay. We'll go in each one of those testing and what means at the moment. Okay. Another important thing that you identify in the test plan is test data. Okay. So what data are you going to use it when you run the test? The example I give you, like creating a dealer. Right? When you want to create a dealer, what all example data that you use it needed in order to successfully create a dealer? If you're trying to use a scenario where it says it should not create a dealer, it should give me an error message, what data you can use? So all the data is important. Typically, your test data should have consideration both for a positive test and a negative test. Right? Positive test is just if everything is built properly, the system will behave it accordingly. And you will be able to accomplish those tasks. Negative test cases and negative test data means I'm going to have certain missing pieces of the data, and system should not allow me to continue the expected time, right? Example, we say if I'm trying to create a dealer without providing the state information, that's a negative test case data. Should not be able to create it. Then we'll also talk through it, how the system is going to be executed. Is it going to be automated or is it going to be manual testing? Most of the systems, when you're building it new, right, you always start with the manual testing. And once the manual testing is working, then you automate it. Unless you're doing something what is called as a test-driven development, where you build the test first before writing the code and then do that. And we'll talk about that towards the later part of the course. Right? So how do you define manual versus an automated testing? A manual testing is something which requires a human interaction in order to execute the test case. Versus automated testing is I don't need any human. I can schedule it and we'll run it by its own. It'll give me the results, we'll pull it somewhere that somebody can review it. Okay. Typically, manual testing, it's where your end users like UAT or end-to-end testing is going to be involved. Automated testing, it's a lot of times it's done by the software development teams or specialized testing team, which has the programming skills to perform it. Okay. It's typically a code-driven or an interface-driven or what is something known as applicable programming interface. Okay, so API, user interface, and code-driven is some certain things that you can automate. Okay, and when we go through some of the automation, we'll talk about how to do all of those. Then you talk through the test velocity. Okay, as you go through it, the velocity is nothing but performing certain activity over a certain period of time. Right. So it'd say, hey, how many test cases I'm running a day? How many test cases I can execute in a day? That gives you test velocity. Right. Let's say you have overall 500 test cases to be written for a system. Right. And you're writing only 2 test cases a day. That's 250 days that you needed in order to do it. Right, but if your schedule calls only like 30 days to write all of the test cases, that gives you a view that if I go at this rate or at this velocity, I'll not be able to meet it. Therefore, either I need to do certain things, either I need to add more testers who can write the test cases, or I need to push the timeline. Or and says out of this 500 test cases, we're gonna worry only about this 200. Right? That's the part of things that you need to do. But that's what the test velocity is around.
Question.
Yes,
So when you write the test cases, do you have to show it to anybody to approve, like they need to approve the test case from the situation?
so we'll talk about that as we write it, right? So typically, it's not the test cases that you write that you need to approve, but you, a lot of times, you just review it with your team members, review with your managers to make sure, am I covering all of the aspects? Right? The test results, when you provided that data, right, somebody looks and says, yes, it is good to go or not. Right? But as we go through it, it's the more emphasis is going to be is, have you covered it and have you reviewed it with others, right? Because similar to everything is a science in software world, right? So I can write the test cases in a one particular way. I can take that system and says, I'm going to test the systems in this way. Harshal picks the same system. He can write few other different types of test cases and says, I'm going to test it this way. There's nothing right or wrong in it, right? It's two different approaches. He decided that this is the way he's going to cover it, all the scenarios. I may decide I'm going to do it different. The more important thing is, are you covering all the requirements? Are you validating it that you have the right acceptance criteria in order to validate that it is working on it? Okay. Then another aspect of test plan is enables you to define what all our different test reports are. So as you go along as a quality assurance, what exactly you're going to produce it that the project team can consume it to say, yes, it is progressing as expected. Right. So they can talk about progress of testing. They can also talk about the quality, right? So depending on how many bugs you created, is it, am I getting a good quality? Or am I getting a quality which is poor that is always requires a rework before it passes? That has an impact, right? So think about it. If I'm not a good cook, right? And if I keep cutting it things improperly or putting in more spices, what's going to happen? It's going to remake the same meal over and over again till it is something that is edible for anybody. Right? Same scenario, right? I'm a poor cook. If I'm a poor developer, I'm producing a poor quality. Well, where it's heavy lifting is going to be the tester. They're going to say, no, this is not working, go fix it. You gave me again, oh, this is still not working. Here is another, right? You're going to end up spending a lot more time in the cycles, right? You want to provide that visibility through the reports as, look, this is how many times the bug is getting recreated and reproduced, still not getting fixed. Okay. And there are various different types of test report, right? Which is what functions are working, when it was working, right? How many defects are getting produced, how long it takes it to fix those defects, right? How many, what is the duration of age? Is it like taking 10 days to fix a defect? Is it taking 20 days to fix a defect? What is the average age, right? And how it is distributed across the systems. Is there one component which is poorer than the other? Those kind of things. Okay. But here are some more examples of the testing status reports, right? And a functional working line. Also, there are certain reports that you can say how many more defects are created versus how many fixed, right? Ideally, you want the defects detected versus corrected ratio such a way that it allows you to finish your work, right? But if you're finding more defects than it's getting fixed, Right, your backlog is gonna keep increasing of the defects that needs to be fixed. Right, your workload to do retesting for all of those is gonna keep increasing it. Right, that's not a very good system. Right. We talked about the defect distributions. Another aspects in the test plan that you identified is how are you gonna classify the severity of the defects? Okay, and how are you gonna classify the categories of the defect? Okay, those two are two different things. Severity, it's typically whether it's critical, whether it's high, average, minor, or cosmetic. So for example, if I'm implementing a credit application process, right, where the dealer is gonna put all the information into it. In that module, if it doesn't allow me to put the customer's name or social security number, that's a critical defect, right? Because I need those pieces of information to send it to lender, so lender can make a determination whether this individual is eligible to get that loan, right? That's a critical defect. If I'm trying to log into the system to test it, but my login doesn't work, that's a critical defect, right? It needs to be fixed before I can proceed it further. Versus high will be, okay, it is allowing me social security numbers, but it is not allowing me to put a cosign. And that was one of that's a high. Can I proceed? Yes. But can I get everything done? No. Right? Average is essentially, hey, it's not allowing me to enter the amount properly. It doesn't allow me the decimal stuff in it. So there may be average that, hey, it needs to be fixed, but I can continue to doing some more testing while you're fixing. Okay. Minor is it's small. Hey, this field, it should always accept the properly formatted date. It doesn't accept properly formatted date, but as long as I put it in the right format, it allows me to proceed. Right. So for example, it doesn't force me the month to be between 0 and 12. Right. That's a defect, right? Because I should not be able to put 15 as a month. Right? Because there's only 12 months in a year. But as long as I put a number which is a valid number, it still accepts it. Probably I can continue with the testing. It's a minor defect that needs to be fixed, but I can still proceed. Versus cosmetic, hey, the background of the page should be green, but it's showing it light green. It's a cosmetic. Right? All of the feature functionality is working, just the appearance is not the right color. Okay, and then there is a priority aspect, right? The category. So the priority is, if I have 15 defects, which one of those 15 needs to be fixed first? Okay, so a lot of times people say, hey, I have 15 average defects. But out of those 15, this 3 needs to be fixed first, because those are important for the functionality. Great. Classify those as a high, categorize others as a medium, something is a low. Right? A lot of times those factors comes into it, who all is going to access the function and how often they're going to access it. Based on that, you identify criteria. So that's the test priority that you identify. Which one needs to be fixed first? Right? If there are test cases, you will also have similar priority. Which test cases I should execute first? Right? So if I run short of time, you always say, okay, if you don't have enough time, which one you have to execute in order to validate the system is working or not? Those are typically categorized as high. If I have a time, I would like to do this and this testing also, probably it's going to be low. Right? Same thing with the defects. Which defects needs to be fixed first? Which defects can be fixed later? Okay. Here are some examples of the product and process metrics, right? So things like how much time the user is involved. versus how much time overall we are performing in testing. That's a process, right? User involvement is how much it's processed. Versus if you do into what is the path testing? Let's say there are 10 different scenarios. Out of 10 scenarios, I've finished testing 2. That's a product, right? Because every product is going to have different number of test scenarios. Okay. Another process metrics is what is the cost to locate the defect? How many actual test cases I have to write it and run it before I'm able to produce the defect? Let's say I spend 500 days and all I was able to find is 5 defects. Right, my average time to find it is 100 days. And then in order to do that 100 days, right, the cost per day is this much. So this is how much it's taking me to find 1 defect. Here are some of the test tools. It's been constantly evolving it. So we'll look through some of those where we will be talking about some additional testing. But the intent is in your test plan, you will identify, here are all the tools that I'm going to use it in order to test the system. Okay. So what we'll do it is this particular exercise will give you remember the third tab that I said is after the requirements, there is a test plan document. So what we would like you to do it between now and next Sunday, read that test plan, review that test plan. Okay. We'll go through that. Before we go into this, let's take, it's an hour, right? It's a little bit, or let's,
This one.
yeah, the test plan, yeah. Okay. So let's do a small little exercise. Okay, all of you read the test document, I'm sorry, requirements and the design document, right? So here's what I would like us to do. Let's do it. Let me see if I can. To so all of you read the requirements document, right? If I tell you that your job is now to test that system, how many days you think or hours you think you will need it in order to test this particular system?
So it's gonna be defined in the spring, right?
Forget sprints. Tell me how many days. Let's say you said, hey, I can do all of those. If somebody gives me that system and I have to test it, I can get it done in 1 day. Or somebody says, how many days you will need? And I say, I need 500 days, right? So based on your reading of the requirements document, your gut feeling, how many days you think it'll take you to test it?
It's a lot.
Tell me, guess. How many days? A month? So 30 working days, you say? Let's say 30 days.
How you break it down, the requirements. And
All I'm just saying is that, like it's Joyce, here is a requirements document. Tell me how many days you needed to test that document. If I give you a system that is in that requirement and I tell you, Joyce, you test it and tell me if the system is working as expected or not, how many days of effort you need?
Yes, person.
Yeah, 1 person.
Then
How many days you will need it?
Okay.
How many stories you're gonna have?
You have that requirements document.
Yeah.
Because that's your first question. When your boss gives you, you need to test the systems. Tell me how long it's gonna take you. That's the first question they're gonna ask you. Right? Think of this way. Right? If I'm building a house. Right? You go to the contractor. And you say, how many days it's gonna take it? Right? Contractor tells you, I don't know how many days it will take me. Are you gonna go with that contractor to build the house?
No.
So
Right?
you would have to
So
with
the contractor is gonna put into it. I'm gonna have probably gonna take this much days, but guess what? The county inspectors are gonna come and inspect the houses, right? Throughout the building process. So they need to include their time also in before giving you estimate. Right? So if I'm in the IT shop. A customer comes and tells me, here's the system I want to build it. Right? So I need to go to my developer and says, tell me how long it's going to take you to build it. Then I need to go to my system within the team and says, if they build this, tell me how many days it's going to take you to build it, to test it. Right? And then what I'm going to do as a project manager, I'm going to add both of those. Right? And then I'm going to tell a customer, this is how long it will take me. And this is how much it's going to cost.
Or it takes like 3 months at least,
Huh?
3 months minimum.
So and that's what I'm trying to get at, your gut feeling. Based on what you know so far, if I tell you that it's like, it's go and test the system. Joyce, you're responsible to tell me the estimate of how long it will take me to test it. You give me so that I can give our customer a timeline. Right? So how many days you will need?
I would go with this too.
Hmm?
We have to come up with the test cases and testing, so.
That's all of your responsibility. You tell me how long it will take you to test. That's what I'm interested.
3 to 4 months, yes.
Okay. Is it 3 months or 4 months? Tell me exactly.
4 months.
4 months.
Okay,
Just recent.
so 4 months. So now the question is,
So can you like give a higher date or time, and then what are we to base early?
think of it, right? You are in competitive there.
Yeah.
So a customer came to me and customer came to Harshal. Right? And says, we need to build a system. Tell me how much it's gonna cost. If you give me higher. Right? If you say it's gonna take me 120 days. I'm gonna add that 120 days. My cost is gonna come higher. What's gonna happen?
Yeah, but-
Customer is gonna come with me or customer is gonna go with Harshal? Right? So if you go to your boss and says, it's gonna take me like 3 months to test this system. Right? What is his reaction is gonna be? How did you come up with this 3 months? Can you tell me why it takes a 3 months?
Because it has a lot of requirements and scenarios we have to come up with.
Right, so what I want you to first figure it out, what is your gut feel? Tell me what is your gut feel, when you say 3 to 4 months. And if I said, great, Saujanya, is it 3 months or 4 months? How did you come up with 3 months? Let's talk it, so that you understand, right? Because that's what, your boss is not gonna ask you, hey, give whatever you needed. Oh, if you don't finish it, let's just do it, add 5 more months to it. Right? Because they want to stay in the business. Your responsibility is to give as much accurate information as possible based on what you know. Right? So you know that I gave you a requirements document. Now let's talk through it, how long it will take you to test it. You're a tester, right? That's what the first thing they're gonna ask.
Depends on the functionality, basically, if it's a complex functionality, it will take longer time, and if it's a simple one, it might take
Yeah,
lesser time, so,
But you all read the requirements document, right?
yeah.
You have an understanding what functionality user wants it. Right? So you tell me, if I'm giving you as a tester a responsibility to test the systems, you tell me how many days you will need. That's what I am asking, a simple question. What is your gut feeling is telling you?
For a single person, 3 months,
3 months, I think, yeah.
Okay, so is it
90 days.
90 days? Okay, we'll go with the calendar days, right? So anybody thinks it's less than 90 days,
Okay, 60 days.
60 days? So you think it's gonna take 60 days? Anybody less than 60 days?
If it's like agile development and this way.
I'm interested, I'm giving you this requirements document, right? Forget it whether you're doing agile, waterfall, and that. Your responsibility is to test that system. Tell me how many days. The process of how we break that 60 days into different chunks, that's a different one. Don't worry about that. Thomas, Sneha, what is your thoughts? How many days?
Yeah, it can be below 60 days too as well.
How many?
45, 45 days, say approximately.
Okay. Anybody thinks more than 90 days?
I'm gonna say it's gonna go for 30 days.
30 days?
Yes.
It's 2 to 3 weeks to come up with the test scenarios.
Don't
Test cases.
Don't judge the other, right? The whole aspect is, what is your gut feeling and how did you come to that gut feeling is the question. Right? Everybody, as I said, if Herschel tests and I tested, we're gonna go different path for sure, same requirement. Right? Does that mean one is right, or other one is wrong? It's not.
No, that's a point.
So if you look at it, right? Just the gut feeling, right? I asked the gut feeling to range from 30 days to 90 days. Right? So you can't just go based on, hey, it's 30 days to 90 days. You can give a customer, it may take 2 months, it may take 2 years. Right? Their response is going to be, I gave you specific requirements. You can't figure it out what it'll take it. I am not going to have too much confidence in you. Right? So you need to think around some process. It's good. This is a guesstimate. How do you validate? Is it 30 days or is it 90 days? As a developer, right? Software developers, they can just give it a guesstimate. It may take 1 month for me to write the code. It may take 5 months to write the code, right? People aren't going to do it. Same way. If you give a wide range without giving a reasoning behind it, they are not going to go. Right? So you need to start thinking around a process, right? And you were on the right track, right? How do I figure it out? First, I need to figure it out. How many test cases this is going to require, right? So you can do some back of the paper napkin type of calculation, right? Let's say you have 9 functional modules, right? You categorize and say, okay, you know what? 3 of them are complex, 3 are average size, and other 3 are simpler, right? And then it says, okay, how much typically average complex modules? Then you take that module and says, okay, if I have to test this, how many test cases, positive and negative, I need it roughly? Right? You start adding that, right? And then you come up with it, how many complex test cases you're going to have, how many average test cases, and how many simple test cases you're going to have, right? You put the numbers around it, right? And says, okay, in order for me to write the complex test case and test the complex test case, let's say it takes me an hour. In order for my average test cases, let's say it takes 30 minutes. In simpler test cases, it takes me 15 minutes to do it. Then you can start adding it up and say, okay, I'm coming to 30 days because my calculation is this much. No, I need 60 days because this requires more complexity. Here is how many more complex cases, right? So you come to an estimate with a reasonable reasoning behind it as to why I came up with that estimate. Okay. So typically, you have to look into it, says, this module, how can I break it down? Now, how do you break that one down? It's going to be different for different people. So you can say, hey, I'm going to break it down by functional modules. Or you can say, there are 5 different types of testers. Right? I have a super users or user, I'm sorry, 5 different types of user, right? Super user, there's going to be dealer, there's going to be R-flown, there's going to be a lender. I'm going to break it down. In order to test the functionality of super user, here are how many test cases I need to write. You can do that. When I'm doing a dealer, I have to log in as a dealer, but all of this functionality is common between dealer and super user. So I can reduce that much, right? You can take that approach. And then you can come up with estimate. Same solution, right? But 2 different ways you can attack it and come up with a different answer. So, I'll show you, like, let's just do a quick 5-minute break. And then I'll walk you through the process of how you still go about estimating and coming up with roughly how many days it will take you to test it. Okay. And then we'll dive into different types of testing from there. Okay. So let's take 5-minute break. It's 10:17. Let's go till 10:25. Let's give it a little bit more break. Okay, so we'll restart at 10:25. What was it?
Figuring out the time and the resources is also QA, right? No.
Well, that's normal job. You have to do that, right? Otherwise, nobody's going to keep you there. So think around, right? What I talked about. You have to first come up with different scenarios, like the estimation. So here's an example, right? You can just say, hey, I'm going to go by user, under which I'm going to break it down into different scenarios, right? So a site administrator, they should be able to log into the system, right? So one scenario is around login. Then they have functionality of managing the dealer, managing the lenders, managing the users, right? So you may add another functionality, right? So they should be able to create credit reports. I'm sorry, credit applications. They should be able to create reports, right? So I can keep adding those different scenarios. And it says, okay, in order to manage the dealer, I can further break it down into different scenarios. They should be able to search it. They should be able to create a new dealer. They should be able to update a new dealer, right? And then I can look into it. Okay, what are the complexity involved in that? Roughly how many test cases I will need, positive and negative. And you can come up with all those numbers. And that becomes one set of input. Okay. Then you can look into something and say, okay, in a lot of times this is our standard template, right? Think around the amount of the time you spend it reading the requirements document. That needs to be counted also, right? Hey, I need to read and understand the requirements document, going back and forth, right? So you talk about, hey, there is a design aspects and there is an execution aspect. During the design aspects, I need to understand what they wanted, need to read through those requirements document. I need to build a test plan or understand the test strategy, right? You need to also factor in how we're going to create the data, how the environment is going to be set up, right? On top of that, you need to do it. Okay, remember, like, it's how many test cases I can have identified roughly, how long it's going to take me to write those test cases, put the step-by-step instructions so that I can execute it at a later time, right? So there's a designing is involved. So you add up all of those effort hours, right? A lot of times you put it like it's a variance of plus minus 10% or plus minus 20%, depending on what your company wants you to do it, right? It says, things is not gonna go as expected, so I need to better allocate a little bit more time. All right, so you put all of those things for design phase, then you say, okay, now once I do the design, I need to test it, right? I need to execute those whenever the software becomes available, how long it's gonna do it, how many times I have to do it roughly. So you put those hours into it, right? Then you also put in the effort that is required to support the users, right? Well, the users are doing their testing and they say, hey, this thing is not working, that one is not working, right? You dig into it, help and says, yes, you're right, I need to create a defect, or no, it is working, here's the way it's expected, right? A lot of times, then you talk about it is once you go live, you're going to still perform some testing. If something goes wrong and it's not working, you go back to test environment to run it and says it is working. Is it an environment issue or is it a defect in the software type of thing, right? So you add up all of those things and then you come up with a number. And that's the number that you give. That's how you come up with, is it going to be 30 days or is it going to be 90 days, right? In this scenario, right, based on the estimate, person came up and said, it's going to take me 67 days to test it. Now, so this are 67 working days, right? So the calendar, it's going to go, it's about 13 and a half weeks. So it's about 3.5 months. Yeah, 67 working days, right? So when you say it's 5 working days a week, you need a 13.5 week to do that. Right? So that's how you come up with an estimate. Now, this is just an example, right? You may come up with a little bit different estimates. Okay, but this is how you go around giving that, because every time your team is going to give it, you need to test this functionality. The first thing you're going to ask it is how long it's going to take it and what all is involved. That's what it's going to be the first step. Okay, now let's talk about what all you need to test it so that you can come up with this system. Okay, what are different types of testing and who is going to do it, what you're going to do it versus what somebody else is going to do it. Okay, any questions before we dive into that?
Where was this in?
It is in your document at the end of that. It's
somewhere
end of
around,
test
like,
plan.
It's in the actual project document.
Yeah, it's right at the last 2 pages of our test plan. The last 2 pages of test plan. The test plan.
Flip tab,
No.
uh,
Flip the test plan tab.
tab,
Flip the test plan.
no, after that, then flip one more tab.
Okay. Yeah. Go to the test plan. The last 2 pages.
There's only one document in that.
That's version. Yes, so it's the last 2 pages of that particular test plan.
No, no.
Oh.
Yeah. Yeah.
Gives you rough estimate. Right? This is the, think around it, this is the process through which you come to the estimation. Okay. So if you look into your test plan document, Sneha and Thomas, it's on the last 2 pages.
They have it in a folder separate.
Yeah.
In our own,
Okay.
online. Or exercise.
Yeah. Okay. So now let's look at the type of testing you're going to perform. Okay. So you will hear a lot of different terms when people are like doing a testing. It says, have you done this type of testing? What is this type of testing? Let's look through all of the different types of testing. Okay. Okay, we'll talk about who runs each type of testing. Okay. So there are different perspectives of testing, right? So first perspective is what kind of testing you do it. Okay, so there is a static testing and then it's something known as dynamic testing. Okay. Static testing is a type of testing that you do it without actually running the software. It's a lot of inspection type of things. Okay. So when I give you a requirements document, and it says, run your 3C and T validation against that requirements document. That's a static testing. So you're reviewing the document and making it sure it has 3Cs, consistent, completeness, and correctness into it, as well as the requirements are defined crisply so that you can test that. Okay, so that's when you do those kind of testing, it's called static testing. Okay. Other types of static testing people will do it is, let's say, Joyce mentioned it, who reviews it or approves my test cases, right? You may be writing a test case and you go to a peer and says, can you take a look at it and make sure I covered everything or not? That's a static testing because you're not running any software. Same thing with the developers when they write the code. They go to the peer and says, can you look at my code and says, did I miss anything or are there any problems with it? Right? That's all static testing. Okay. The whole purpose of that is to verify. Am I completed right? That's the purpose of static testing. Now, it occurs throughout your life cycle, right? When you do it, whether it's a requirements review or whether you're like it's doing your test casing or test cases review or code review, all of those things is known as static testing. The other flip side of it is it's dynamic testing, when you actually have to run some sort of software in order to test that. Okay, here the purpose is I'm going to validate it works as expected. Okay. You can do it functional or non-functional testing, and it also happens throughout the life cycle. Okay. So the developer will do a unit testing, you will do it end-to-end testing or system testing. End user will perform the user acceptance testing. All of those things are dynamic testing because it requires you to run the software. Okay. Now, another view of looking at testing is something known as a black box versus a white box testing. Okay. A black box testing is something that you do it without knowing internal of how it's working. Okay. So you're treating whatever you're testing it as a black box. All you're providing is input and validating, is it giving me the right output or not? Okay. You have no knowledge of how things is built internally. Right. So for example, if I just as a user comes up and turns on and off this switch, I have no idea how the wiring is done or how things is done, right? All I care it is if I turn on that switch, is the light turning or not? That's black box switching. Right? It focuses on testing what is software supposed to do. Okay. A lot of times people will tell you it's a specification based testing. I'm going to specify what it's supposed to do it, and you test it whether it's working there or not. Versus white box testing is essentially I know it how it is working. Okay, so I know exactly how the different connections are made it from the wiring to there, and based on that, I'm going to test it that I may run a test case that is the wiring properly joined. Right, in a black box testing, I don't worry about writing that test. In a white box testing, I'll just is it properly joined? Is positive connected to positive? Is negative connected to negative? Is the ground connected to ground? When I do those kind of testing, that's with the internal knowledge of how the system is implemented. That's called a white box testing.
So this can only be done by the developer, right?
Most of the times it is done by developers because they have known how many paths versus specification-based testing is typically done by tester because they don't care how it's internally implemented. They're just saying is the functionality working on.
I guess we all do, so we're kind of testing all the time then, like as you use a switch. If I go with an apartment now, it's better than a switch, the light will work. So if I turn it on and it doesn't work, then I can call the hey, it doesn't work.
Yeah.
And if it's work,
Then it's working as expected. Right. Yep. Okay, the same concept goes in the software development, right? If I know exactly how it's implemented, that's a white box testing. I don't care how it's implemented, I'm just making it sure its functionality working as expected. Black box testing. Okay. Then it talks about the unit testing. Okay, so now you go into it and says, what are different types of testing you do, right? So one perspective is static versus dynamic. Other perspective, it is white box versus black box. Now it says, what type of testings are doing? That perspective is unit test. Remember, like it's in the V, we say that at the bottom, it's a unit test. Okay. This is, I'm trying to do a specific piece of code or functionality is working as expected or not. In this scenario, I know exactly what the code is. All I'm trying to make it sure, can I test it to every possible path and making sure it is working as expected? That's a unit testing. Happens way early in the development life cycles, typically done by a developer. So you as a quality assurance person or tester doesn't get involved into that. Okay. Typically, the people who write the code are the ones who are writing the test for it, also unit test for it. Okay. Then the next step comes in is integration testing. So I wrote two pieces of code. I need to make sure they both work together. Right? So I'm going to perform an integration. A lot of times we talked about link testing. Right? Are those two programs linked up properly? Are they working as expected or not? Developer exactly know how those interactions work. They are the one who is performing this testing. Okay. It is still done during the development phase, but typically after the unit testing. After my two individual components are working, I'm going to bring it together and making it sure they work together as a one piece. Okay. I'm going to skip this two for a moment and I'm going to come back later. Okay. The next one is a system testing. My individual components are working together, fine. Now I need to bring it all the components together to see if it works as a system. Right. So for example, I log in into Rflow. And then can I go ahead and like it's view a dealer? Manage dealer functionality versus login functionality. Are those things working together in a one system? That's a system testing. Typically, this is done by the testing. And this is done once the code moves out from a development phase into the testing phase. Then another term it's you're going to hear commonly is a regression testing. Okay. This is a type of testing which is done to still validate the piece that was working before it's still working. So let's say you were doing a system testing. You identified a bug. You gave it to the developer and says, this needs to be fixed. They fix that and says, here is the new piece of software. Okay. At that point, you need to make sure everything that was working before is still working.
Oh, okay. On the beginning.
Right. And now what they gave you is fixed and it's working. Right. But you still need to do it while they fixed that piece, they didn't break anything else. When you validate that, that's called a regression testing. Right. So it is verifying that previously working part of the software is still working. That's called regression. It's something that was working before, I'm retesting it to make sure it still works. Okay. It's typically done during the testing phase. Because remember, like this is when I had a bug, you fixed it, you gave me because I was already in the testing phase. Okay, and it's performed by testing. Okay. Okay, let's come back to the two ones that I skipped in. Okay. Now, I identify a bug. Give it to developers, they fixed it, they give me a new piece of software. Okay. First thing I need to check it is whatever they give me, is it good enough to start my testing? Okay. So let's say an example. I'm testing a website functionality. There was a bug, I gave it to the developer, they gave me, and they said, here is a new piece of code, I have to install somewhere, right? And I go to that URL that they said it's fixed and this is deployed. When I log in, do that URL, let's say whatever the CNN.com or whatever the URL is, nothing shows up. Can I continue with testing? You can't, right? Because it's most likely it tells you things is not working as expected. It's not, software is not even installed properly. Therefore, I can't even start my testing. Right? When I do it to validate, is the software installed properly so that I can start my testing? That's called sanity testing. Right?
So what's the difference between regression and insanity testing?
No, regression testing is already had a functionality working. The system is already working. I'm retesting it to make sure it still works. Sanity testing is, I got a new piece of code. Is it good enough that I can start my testing? Okay. One is, I'm already testing it. It is working and I'm revalidating whether the thing is working or not. That's regression testing. Sanity testing is, you gave me a new piece of code. Is it even good enough for me to start testing? That's called sanity, right? So is it reasonable for me to proceed? If I give you a new URL and that URL doesn't even work.
So sanity testing comes first and then regression first.
But sanity testing, the reason I skip those two is, unless you start doing a testing as a testers, and they give you a new piece of code, you will never encounter sanity testing. Sanity testing is it good enough for me as a test team to start the testing or not? That's sanity testing, right? Typically happens whenever a new code is released into test environment. Remember, like the three environments I was talking, here's the developer domain, here's in the middle is the test domain. When they give you a new piece of code, that's when this triggers. Is it even worth for me to start testing? Or you give me a piece of code that it's not even installed properly, so I can't even start it. That's the purpose of sanity testing. Smoke testing is a little bit different, right? You gave me a piece of software. I'm able to pull up the URL. Great. But the first functionality requires me to log in. And what does login require? Typically, remember, it's when you talk about multi-tier architecture, you have a presentation tier, you have a business tier, you have an application tier, and then you have a database tier, right? Can you log in if all the tiers are not running? Most likely you can't, right? Because your login credential is stored somewhere in the database, right? Just because your web tier is up, that doesn't mean your everything is in system is working and up and running for you to begin testing, right? So when you do certain ad hoc testing to validate, are all the parts and pieces of system up and running or not? That's known as a smoke testing. Okay. So if there is any basic problem that prevents me from working the software, you may have application working just fine, but database is down. Every time you log in, you get an error message. Can you proceed? You can't proceed much. So if there are multiple components, if all the components are working or not, if you're doing testing to validate is all component working or not, so that I can proceed with reasonably with the testing, that's known as smoke testing. Okay. A lot of times people combine sanity and smoke testing together. That's okay, right? But there is different terms. That's what they use it. Can I even get started? Versus everything working so that I can test reasonably well. Okay. Whole purpose of this thing is to verify build, is all the components working together as expected or not? That's what the purpose.
But what do you say component testing, but smoke testing, smoke is like being, confused. But they could have said component testing.
The component testing is a completely different term. Right,
So,
when you talk from a testing point of view, you're thinking from a whole holistic picture. Is everything up so that I can continue testing or not? Right, so when I think around it, when you're building a house. Right, and you want to start testing it. You want to make sure if the frame was built and electrical system is already wired up. They both are working before you can start doing additional testing, right? That's the whole purpose. Smoke is every component that is available for me to work it. Are they working before I can go and start doing intercomponent testing? Then it comes. Then aspect comes in, right? So now you've done it. The end-to-end test, system testing, right? Integration testing, system testing, unit testing is done. You've done the regression testing. And talks about a different perspective, functional versus non-functional testing. Right? So functional testing is you're thinking from a user's point of view. Is the system functioning as expected or not? Right? Then that's a functional testing, right? I'm verifying the functionality of the system. Can I create a dealer? Can I create a user? Can I create a credit application? Can I approve a credit application? All of those are functionality of the systems. When I'm doing that test, that's called functionality testing. Okay. It typically happens during the testing phase of the software development cycle because you, as a quality assurance person, is testing all of those functionality. Versus load and performance testing. Those are typically non-functionality testing. Right? You still, as part of performance test, I'm sorry, part of testing team, you also say, is the function is working, but also if there is a requirement, it should respond back within 2 seconds. You're still testing that. Is it usable? You're still testing that. Those all are part of non-functional testing. But also some of the non-functional testing is done by load and performance teams. So when everything is working as expected for one user, you perform the functional testing. Now it says, okay, take that same functionality instead of one user, if there are 5,000 users, is it still working as expected? Am I still getting response time on a timely manner? I'm still getting the right data to the right user, right? All of those things is known as load and performance testing. You try to answer a question, can system continue to perform under the expected load? The keyword there is under the expected load. Okay. If I've designed system for 500 users, is it still responding it when 500 user logs in and works at the same time? That's load and performance testing. Now, this thing is typically done only after your functional testing is working, right? Because if certain part of functionality is not working, how good it is to test it? Doesn't work for 500 users? Heck, it doesn't work for 1 user. Why even put an effort to see if it works for 500 users or not? Right? So typically you do the load and performance testing after your functional testing is completed and passed. Okay. Now, this requires some additional skills. Right? So a lot of times you may do certain pieces of the load and performance testing for small things by the same team, but often it requires programming skills because you have to program such a way that you can simulate 500, you can simulate 10,000, you simulate 50,000 users, right? So it requires some programming skills. So a lot of times in the big companies, you may have a different load and performance testing team. then your functional testing. If it's a small firm, then potentially they expect you to pick up that skill and do both the capabilities. Then there is a stress testing.
Do you need any coding for this?
Performance testing, yes.
As
you
a
need-
tester, we need any such skills.
When you're doing a performance testing, there are two different types of load and performance testing, right? One is, what do you call it, is record and run. For that, you don't need a lot of programming skills. The other aspect is you write the scripts to essentially simulate it and then run those testing. In those cases, you do need a programming skills. So it depends on what you're trying to do it on the load and performance testing. We'll do certain basic, like it's record and run type of performance testing, load and performance testing here. Right, but the other one, like it requires programming skill, that's a different additional. Okay. Another aspect is known as stress testing. Okay. Stress testing is not done normally on a regular basis. It's kind of optional testing. That's the problem. It's an optional testing. When you try to see it, at what point system breaks. So let's say you did 500 users, works fine. It says, okay, but how many more users the system can handle? It says, okay, let me keep 1,000 users. Still works for 1,000 users. Okay, what if I add another 100 users? Then it breaks. Right now it doesn't respond as expected. So then you say, okay, system works up to 1,000 users and it breaks it when I add additional 100 users. That's a stress testing. Okay. A perfect example of that stress testing is it's trying to figure it out when the system doesn't work and breaks it. Okay. I don't know, I'm kind of like it says, I've watched a lot of science and space type of movies. Have everybody or anybody has ever watched a movie called Apollo 13? Yeah. So that movie is around NASA's mission back in 1969. When they were trying to put the humans on the moon. Okay. They were like, it's doing a mission called Apollo, right? So the whole series was Apollo and they did 11, 12, 13, right? So the 13th one was like, it's essentially was the third mission going to the moon. They're trying to put the 3 people in the moon, right? On the way there, so they left it from the Earth, way there, explosion happens and spacecraft crippled, right? It's not like you're driving a car on a freeway. Doesn't work, you stop it, you get out of the car, try to fix it, right? It's a little bit difficult when you are up in the space and when you don't have all the tools to fix it, to figure out what the hell happened, right? But then they try to say, okay, the spacecraft is not working as expected, but there are 3 humans on it. You're halfway between Earth and Moon. How do you bring those 3 people back alive? Right? The whole movie is around that. It's essentially the effort of how NASA got those 3 astronauts back on the Earth, right? So they decided, hey, it's the best option to bring them back alive is not to turn around and come, actually let them go all the way to the moon and then use the moon's gravitational shot to bring back them to the Earth. Okay, but they say in order to do that, that's going to take another 3 days to do it. Right, half of your oxygen and system resources not working. So they said we need to conserve power, we need to conserve the oxygen. How do you do those? Right. So they had another sets of astronauts working on the ground, simulating exact same condition and figured it out at what point things break. So how much they can push it, the oxygen limit, the battery limits and everything before it breaks it. So the movie is all about that, right? But the concept I want to think around it, that's a stress testing. They figured it out at what point it breaks it so that they avoided pushing the system to that point so that those 3 people can still stay alive and come back to the Earth. Okay. Stress testing is figuring it out at what point system is going to break it So that when you are in a live environment, you don't push the system to that level. Okay, another perfect example, 911 system. Okay. I worked in telecom company for like 20 years. When actual 9/11 happened, I was in the telecom firm. Right? Most of the telecom systems are designed to have it, okay, if there is 100 people living in that area, probably only 10% of them it's going to be on the call at the same time. Right? So they do the load factor based on a population to load factor. And that's how we do it, load and performance indexing. Guess what happened that day? Everybody and the brother was trying to be on the phone, trying to figure it out where the loved one is in the New York system. Right? People from outside the New York, inside the New York, trying to get access to 911. What happens? System was not designed, it went through the stress and it failed. Right? The impact of that failure? People could not go through it for 4 or 5 hours through the call to talk to the people. That's stress testing, right? So you're trying to figure it out at what point the system needs to be loaded to break it, right? They're trying to do it now to a point where, okay, if system goes under the stress, how you can route it across the different and still make it that happen. Right? But then will still be a failure point, no matter how many routings you do it, right? So the whole purpose of those stress testing is on the mission critical systems. At what point it's going to fail. So that they can put the steps in place so this system never reaches that, right? It is better for not allowing people to make the call rather than forcing them that it's not going to connect it, because then everybody who is still can make the call cannot make it call either, right? So that's the whole purpose of stress testing. As a tester, you figure it out, what are the failure points, so that the business can make appropriate decision. Okay, this is rarely done, and it's a very expensive testing. Okay, because it involves failing the system. Okay. And typically it's done by testing, but there is also a specialized skills that goes into it. Okay, very rarely you're going to see it, unless it's a life support systems. You're not going to see them doing a critical failure system. So for example, you go into the space systems, you're going to do this, right? You can do any of the life health support systems, whether it's in a healthcare or if it is in the 911 type of systems where people's life and death situation is there. You're going to see this kind of testing. Okay. Once you're done with all of those testing, once you validate the system works under expected load as it's working as functional, you turn over to your users and says, you need to do the user acceptance testing, right? Think around, if you're building the house, right? Contractor does their own testing. County inspectors do their own testing. And then they just give you and says, okay, as a user, your house is working, you do a walkthrough. You do all those inspections, you turn on whatever the light taps that you want to turn it on, right? Make sure everything is working. That's your user acceptance testing. You as a quality assurance team, finish testing, everything is working as expected in the system. The software is meeting its fit for purpose. You give it to the user and says, now you run the test and see if it's working or not before you do the final acceptance testing. Right? So this is typically done by end users. But more often than not, you're going to find that the user is going to say, I want you to do this testing on my behalf. You go do it. So the quality assurance team or testing teams performs this testing a lot of times on behalf of the users. There will be scenarios where users will be involved, but a lot of times they may ask you to do it, right? So this is performed by you or the business users, and that's what it's happening. Okay. That's all happens that once the user finishes that testing, then typically then you go into the acceptance aspect in the life cycle, right? Testing is working, system is expected. then you do acceptance testing. There is another aspect that you're gonna do it depending on what the purpose of the system is. Something known as the back-end testing. Okay. So far, all of the testing, the functional testing and everything that you talked about is done from a user perspective. It's done through the user interfaces. But there may be a requirement that doesn't involve any of the user interactions. It needs to perform in the backend. Okay, for example, right? So one of the requirements is around audit, right? It says that every time any transaction is performed, it needs to be captured and logged into the system. Who made the changes to this? So anything with the credit applications, right? It's a financial regulations. So it requires anytime anybody performs any changes, they want to capture it and store it into audit logs so that that can be accessed by auditors at a later point. Okay. It's not visible to end users, but you need to make sure a system does that. So often, right, it requires you to log into database, perform the queries into database and says, did that information got stored? Who changed it? What changed it? And when it was changed? Right? So if you perform any testing, which doesn't involve the user interface, it just goes into backend and making sure if they submitted the credit application, is it showed in the right status? Can I log into the database and see that? That testing is known as a backend testing. A lot of times it's a system to system or database type of thing, right? So for example, the e-commerce system that we talked about, Amazon example. I'm trying to validate, is the payment valid or not? Often you can do that all the way end to end, or you can say, I'm banking gateway in my application. Does they connect and talk to each other or not? If I give them, here is the credit card number, here's the amount, make a call, does it respond to me or not? All of those things is the backend testing. It doesn't involve the users. You're testing system to system communication. Is it working as expected or not? That's called a backend testing. You will perform as a testing, a lot of this testing. Okay. As we go through it, we'll talk about the web service testing. That's nothing but a backend testing. Then in addition to all of this application testing, when you start thinking around a web application, which 99% of you will be involved in web testing. Okay. Most of the application now it's built in such a way that it can be accessed from anywhere in the web. So you're going to encounter that. So those are system function regression testing that we talk. But when you put the hat up, hey, I need to test the web application, there are other aspects that you need to think around it. The first one is usability testing. Okay. So is it user-friendly? So if I'm trying to log into the system, let's say if I go to my banking system, or even has everybody used Amazon? Right? So you go into the Amazon, right? And you said, I want to check what is my gift card balances. Is it easy for me to go through do that? Right? Because I'm not ordering, I'm not just looking there, right? I'm going to my profile, checking into my payments and checking into how much balance is there. Or if I'm trying to figure out what all shipping addresses I have stored in the system. What all are my past orders? And I want to go look into what I ordered into January of 2022. Right? Is it simple and easy for me to go use that? Okay. When you do those kind of testing, you need to think around, is the system friendlier and easier to begin? One company which does an excellent job in the usability testing and user interface is Apple. Okay. Give your iPad to 2-year-old kid. You don't have to explain them what to do it, right? All the applications are built in such a way that they are easily intuitive and friendly to use. That's a usability testing. Right? Is it simple enough for you to use it? Or do I have to give you like 30-page manual to say, this is how you do this function? Okay. Another aspect, we already talked about functional testing, right? If the system doesn't behave the way it's expected, even if it's very friendly to use it, nobody's going to use it, right? So as a quality assurance person, you think about it, it's not only usable, but it actually performs all the function that's expected. Okay. Another aspect that you think around what is known as compatibility testing. Okay. If your application is supposed to work only on one user, then you exactly know what is the configuration, what version of the browser they're using, right? Life becomes easier. But if I'm building an Amazon.com type of applications, and I have millions of users accessing from their machines, I have no idea what browser they're going to access from. They could be using Chrome, they could be using Edge, or the Mac platform, they could be using Safari, right? There are a whole bunch of browsers out there. And guess what? Each browser also continuously evolves, right? So they have versions, like Edge had Microsoft Internet Explorer has version 5, 6, 7, 8. Now they've done Edge. Edge has a different versions, right? You need to make sure your application works on all of that, right? If you use a right click on the mouse and build some functionality, great, works on Windows. Guess what? Mac doesn't have a right mouse click version. But somebody accessing it from phone, they don't have a right click mouse there. All they have is a touch screen, right? So if your system works in all of the intended environment, providing that functionality, that's what the compatibility testing is. A lot of times, you can't just predict the whole world and trying to do testing, right? It's impossible to test all of that, right? So you ask the user and says, okay, this application, can you identify what all browser version it needs to work on and what type of browser it needs to work on? And you perform testing on all of those. Okay. We talked about the database testing, right? Backend testing. If I enter an order, how do I make sure the order is entered in the system? Right, that's database testing. Another aspect is security testing. Okay. So if I'm logged in as a site administrator, I can perform a whole bunch of tests, functionality, right? But if I log in as a dealer, I should not be able to do everything the site administrator does, right? That's a security. Depending on the type of the user I logged in, does it everything. That's one aspect. Another aspects of security testing is if I'm doing a web, right? All of my data is going over public internet, right? I don't want my social security number or credit card number tapped and read by anybody. That means it needs to be secure, right? A lot of times people say it needs to, what do we call it, is you're going to communicate over SSL connections, right? Or a lot of times when you see it in the browser, right, there is a lock right next to the URL, which says that it's a secure traffic. You need to test all of that. If I'm sending a social security number from my browser to the backend system, is that connection secure? Is it encrypted? All of their aspects are security testing, and you need to test that to make sure, is it secure? Is the communication going over secure connectivity? Okay. That's all aspects of the web service testing. And the last aspect is performance testing. Okay. I go over the internet. Sometimes it's very slow getting. Right? Is it reasonable still, depending on what type of internet your connection, right? So they said, hey, in earlier days, which some of you may not even remember, right? There used to be dial-up connections. There was a 14K connections compared to what you now get as a gig connection, right? is the system still working and if somebody connects it through the 14K connection? Right? If the image takes forever to download, my system still works? Does it replace the image with alternate text so that functionality is still quickly visible? All of those things is part of the performance testing. Okay. Any questions? Does it give you a view of when people throw different terms? I'm doing regression testing versus system testing, performance testing. Do you understand what each one means? Okay. Any questions online?
No.
How do you do the security testing? I mean, can you just elaborate a bit more on that?
So depending on like its type of, right? So if you're doing a role-based security, then obviously you log in as different users' credentials and do those testing and says, does this user or this account can do this functionality or not? So that's one type of testing. The other type of testing is typically you see it whether the connection is secure or not. So there are two ways you can do it. You can look into the browser, you can intercept that code that has been sent from the browser and can make sure that it is secure or not, right? There are tools that you can utilize it for that. Simplest way you can just see it is in the browser, right? If you look into it, it will turn on the flag. You see it if I can go to the browser.
There is a penetration testing and.
Yeah. I'm trying to like it's get out of. Just the. Okay. So look at right if I go to CNN.com. Right, you see this thing? Where my mouse is? You see the lock? Right? And you will see it that this is, it's no longer HTTP, it's HTTPS. So it tells me it's a secure connection going to that site. So any information I put in here, it's going to secure before sending. Versus if you just go to, let's say, this one also goes.
Yeah, I think these days.
These days, everything is secure stuff because there is a login and some of that. But that's the indication, right? So if you see it. See everything? You always see a lock and HTTPS. If you don't see that lock, that means the connection, all the information you're sending, it's not encrypted, it's not secure, it's sending it. That's how we do the secure test, right? A lot of times you can intercept the calls through the tools and says, when they make the call, what exactly is the content it's sending it to that server? And then that also the way you can see it if it's secure or not. Okay. Any questions? So those are the ways that you can think around these terms. As we go through it, we'll start doing it simplest functional testing. And then we'll continue with the regression testing. We'll do backend testing as we go through over the next few weeks. Okay. All right. The next aspect that you need to think around is a defect management. Okay. So as a quality assurance person, as a tester, when you're testing things doesn't work as expected. You raise that as a defect. Give it to the developer to look into it, fix it, and give it to you, right? So you need to start thinking around how you're gonna track all of that effort of you identifying something not working, the developer fixing it, coming back to you, you testing it and see it's validated, whether it's working or not. That entire aspect is known as a defect lifecycle management. Okay, and then there is a process around it for tracking, prioritizing it, and doing an impact analysis around it. So the purpose of this one is to understand how and what are the defects. Okay, so here is the Wikipedia definition of software defect. Okay, there are a few things you need to consider when you're looking at this slide. Okay, the first one is defect is nothing but an error or a flaw or a failure. Okay, and as a result of that failure, your system produces an unintended or unexpected results. Okay, remember when I say it's you get the requirements, the first thing you do is identify acceptance criteria. Okay, when you test a system and it produces results that doesn't meet that acceptance criteria or expected behavior, that's a defect. Okay. A lot of times you'll hear the word defect versus bug. Right? They are more or less kind of same thing. People will intend to tell the defect as same thing as a bug. Okay. With the category or with the caveat that if your system behaves unexpectedly, but that result was because the requirement was not clear or it was an unambiguous, then it's not a bug. Okay. So if you identify, hey, system is behaving this way, and the user says, oh yeah, I forgot to tell you the requirement. That's not a bug. That's a missing requirement. Okay, that system is still behaving as it's described in the requirements document, but the requirements document was not complete. That's a different problem. Okay. So here's the process or life cycle for the defect. Okay. Whenever you're working through it, as a tester, you identify something that is not giving you expected results. Okay, you raise that, hey, if I do this in this scenario, it is giving this instead of this is what was expected. Okay, what you do it is when you encounter that situation, you open that defect. And that defect then gets assigned to somebody in the development team to work with. Okay, so the first thing they do it is they look into it and says, is it truly a defect? Or is it a problem because there was a missing requirement? Okay, or you as a developer are following the same thing was expected in that, but as a tester, you missed that requirement. You didn't identify the right test case. You need to fix your test case. Your system is working as expected. So you need to change your expected results. Okay, that can be scenario, right? So the developer or development team is going to look into it and says, is this truly an issue? If it is not an issue, they're going to reject it and says, that's not a bug. That is expected behavior. You need to fix your test case. But there will be scenarios where it says, yes, system should behave this. It didn't behave this. I understand there's a problem with the system. So they take that issue and says, we're going to work on it and we're going to fix it. Okay, so they move it from an assigned state to essentially under development type of status because they're accepting it. Okay, or they could do a rejection, because it's not an issue. If it is a thing that they're gonna work on it, they will start working on it. Once it's done, work, they will flag it as that this issue is fixed. Okay. And then at some point, they're gonna say, okay, now I'm gonna take that fixed version of software, I'm gonna give you that to test it. When they give you to test it, they will flag that as, okay, this issue is fixed and it needs to be verified by the testing team. So they will change that fix to be verified. Okay. You then, as a quality assurance or a testing team member, go and says, okay, they give me a new version of the software. I'm gonna look at that, what all defects are fixed. I'm gonna first test those defects to make sure, is it now giving the results as expected? If it does, then I'm gonna say it's okay, issue is fixed, I'm gonna close the defect. If it doesn't, then I'm gonna say, no, the change that you did didn't fix the issue still. You need to go back and you're gonna follow the same process again. Okay. That's one thing. Now, while you're doing this, remember what we said, you still need to validate it. While they fix that, they didn't break anything else. You're gonna do regression testing. If you found that they break something else while fixing this, that's a new defect that you're gonna open. It says, oh, when you fix this was working earlier, it's now no longer working. That's a defect. Okay. So that's how the defect lifecycle goes on.
So that would be like a sanity testing?
No.
When-
Regression testing.
Oh, I'm just saying, when you see a bug and they accept it, and they fix it, and they give you another,
They give you another bill, right? First thing you do it is it ready to be tested? If it is, then you still need to test that specific scenario that produced the bug earlier that failed. You still have to test that. That's still a functional testing.
Oh, that's not a sanity.
Hold on. Okay. Any questions on this? Do you understand how those cycle is going to work between the defect management and the testing team?
So then you do a functional and then regression test.
Right.
I'm missing a page here.
Hmm?
I'm missing a page here,
Which page are you missing?
47, 48.
Okay.
I'm missing a page.
You're missing it, we'll just probably print it that page for you. But you should also have access to the online version. You should have the receipt. Okay. Okay. Now that you have understood the defect process, right? Every project that you work on it, right, it's gonna have a defect management process. Okay. And any defect management process, when you look at it, right? The first goal for you is to prevent it, right? You want to put the steps in place so that the defect doesn't get introduced in the system. Okay. If it is, nobody's going to be perfect, right? So there's going to be a defect that's going to seep in, right? When it seeps in, right, then your goal is to find as early as possible. Okay. And if you're not able to find it as early as possible, or whenever you find it, then you need to focus on how you can minimize the impact of that. That's the whole defect management mindset, right? Prevent whenever possible. If it's not possible, identify as early as possible. Once you identify, minimize its impact. Okay, that's the defect management. As you go through the life cycle, it becomes more and more costly to fix it. Okay. And it's much more easier to prevent it rather than detect it and fix it. Okay. Here is the data from hundreds of projects that a study conducted. And it's around what is the cost to fix the defect. Okay. I'll give you an example, right? And then that should resonate you well. Remember we talked about building the houses, right? If you build a house, after everything is built, you find that it has a plumbing and electrical problem. What's gonna happen? They will rip apart all of the drywall to see where the plumbing issue is happening, where the electrical problem is happening, fix it, and then put it back. All of the drywalls, sometimes a new drywalls and everything, right? Pretty expensive, isn't it? You have to rip up everything, right? And not to forget the reputation of you as a builder, that you can't build the things properly. There are issues, you don't have things that, right? So next time that person is gonna talk to their friends who wants to build a house, they say, avoid that guy. Right? Because it cost me 4 months delay, it cost me this much more time. Right? And sometimes it cost me this much money because I have to deal with that. I couldn't move in the house for that 4 months. I have to find somewhere else to live in, and it costs me more. Right? Depending on the contract, all of them may go to the contractor and says, you need to pay for my reimbursement for that. Right? So the cost of finding a defect in production is much more expensive. A, you do all the rework, there is a reputational cost. Also, right? Think it from a software point of view. If I'm a bank and I deployed the code into production, right? And it doesn't do the deposit into the right account when somebody says it. Think around the cost of it. You not only have to fix it, the issue, there is a reputation, there is customer loss. Plus, you need to spend time to go back, fix the software. You have to validate that nobody else was impacted. Whoever is impacted, you have to go back and adjust their accounts appropriately. You have to notify them. Right? Think around the amount of expenses that you have to do in addition to the reputation. Right? Versus the same issue, if I found it in production, I don't have to adjust anybody's account, right? Yeah, I have to go back and redo the code, retest it. That is expense, but it's a lot less than whatever they found in production. Right? So the cost of doing, if I shift that defect detection from production to test, I can save so much expenses. Now that thing goes into the code, right? So if a developer finds an issue through the unit test, guess what? I don't have to have a testing, do all the regression testing, do all the functional testing on the defect code. I can save all of that thing. Versus if that would have found in the test, they will have to do code fix and then have to rerun all the tests for regression to make sure everything is still working. Versus if I identify that into the design, no code, nothing is done, right? No developer has spent the time. That's, oh, instead of this way, what if we do it this architecture? It's probably going to meet my need better. Versus if I find in requirements, right? So when you were doing 3C and the t-test, you identify, do you want this or you want this? No code is ever written. The only amount of effort is spent is you as a quality assurance person, BA and a user spending some time reviewing the document. Right? So the earlier in the life cycle you find the defect, the less cost it is to fix it. Right? So your goal as a quality assurance person is to see how can you shift detection of a defect as early as possible. Okay. And ideally, you want to put a process in place so that the defect doesn't seep in. Right? You should just say, hey, a BA, when you're talking with the users, get all this clarification so that we don't have to review and go back to the users to do that. Right? That's the mindset. Put the process as possible to prevent them from occurring in the system. Okay, so that's essentially a defect management process, right? You put into the prevention mechanism in place. Things occasionally is going to seep through it. right? So you put a process in place to allow you to detect it as early as possible. Based on that, you understand how you're resolving those defects. You take that feedback of how we can change the process. And then you go back, right? For example, you say, hey, I'm losing 3 days every time a new software build is given. Because things doesn't work, right? You can put a process in place that, look, as a developer, I had to spend so much time identifying so many defects that why this was not working, this was not working. If you put a process in place that when you do a deployment, you do it in this order, so everything works perfectly when you install the software so that the testing can start on time. That's a process improvement that you're doing. Okay. Now, defect tracking is nothing but a process of tracking the defect from the time it's identified till the time it's resolved. Right? So that you have a clarity as where exactly in the system it is. Is it being fixed? Is it waiting for it to be verified? What exactly is the status? Now, there are softwares that allows you to do it. A lot of things, what you're going to see it is what's known as the application lifecycle management tools, which has built in those capabilities that allows you to associate the defects, allows you to automatically track and get those data. Okay. The whole goal is at the end of the day, you want to understand what are the details around the defect so you can do an analysis so that you can make a process improvement to essentially become a better at identifying it and resolving it earlier in the cycle. Now, what does a typical defect has associated information? Okay. So when you look at that, obviously you want to make sure every defect is uniquely identified. So there's going to be some sort of ID. Okay. But we are a human, right? ID, if I tell you it's a defect 23, unless you're involved in that 23 doesn't mean anything. You tell end user, we have 40 defects, here are the numbers. What good it is to the user? Nothing, right? So you want to have some sort of type of the defect and some description associated with it. It's a login defect. They can probably make it better sense of that something is a login defect versus defect number 22. Right? Then you want to identify where did it originate? How did I find it? Right? What is the severity and priority? Remember we talked about the priorities and severities when we talked about test plan? Well, what are those things? What is the status of the defect? Is it open? Is it closed? Is it waiting to be verified? It is still to be assigned. What exactly the status is? Okay. Then you talk about actually when did I find it first time? When was it last updated? So that I can understand how long it has been in that particular state. Do I need to do any action so that it can be looked at quicker? Okay. The descriptions. Sometimes the description also talks about what exactly you were performing it that led to identification. What are the steps? Can I reproduce it? Right. You can say, hey, go to this site as a login, put this user ID and a password, and it gives you a failure. It's much more easier than say, hey, it's a login failure. People cannot easily reproduce, right? But if you tell step by step what they were doing it, then it's easier for a developer to say, let me go try it in my development environment to see if I'm getting the same error. Okay. As part of it, it's screen pins, logs, whatever helps you to do that. Okay. Who is working on that? Then we talked about the priorities. Right. Same thing as the test case priorities. High, medium, low. If there are defects, which one I should tackle first? Where should I put my effort to fix it first, compared to which one can wait for later stage? Okay. Then we talk about the criticality and the severity, right? How important is that defect? What is the impact? Right? Critical defects are typically the one that has a bigger impact. You're not able to test a whole bunch of other functionality because this defect is present, right? If I can't log in into the system, I can't test anything. So that defect is going to be very high. Versus, hey, I can submit it, but it doesn't force me to enter all this information. That's a little bit lower than login. Versus, hey, I have a defect. The button should be on the bottom right, but it shows up in the top right. Well, the location, you can still perform all the functions. It's just that the navigation, I need to do it a little bit differently, right? So those are the kind of different types of defects. Now, in terms of reports, the defect reports, you can look into it as how many defects I'm generating on a daily basis, how many are fixed, what are the distribution, right? How many defects are in managed lender versus managed dealer versus login module, right? So if there are multiple components, you can say it's defect by components and identify what is detected versus connected. Here is an example. And this is, in order to fit into a slide, I kind of just put it only a little bit of information, right? But when you get into the systems, the ALM system, you will see a defect has a lot more details. Okay. But when somebody looks at this report, right, they can just say, hey, I have 3 defects that is pending, that is currently open, right? Here are the status for each one of them. Here's the component in which they are located, right? One is a database related defect versus another one is application, another one is security. It gives you some sort of idea when it was open and when it was last updated, right? So you can see it like it's this defect is probably not even worked on it versus this defect, people have been working on it, right? There are some changes occurring to its status from open. And here is high level summary. So you can just quickly look at it, right? So if somebody describes to you, hey, I cannot enter more than 250 characters. That makes more sense than somebody says that it's a database defect number 23. Right? But by looking at people can just classify the different things and work through the questions. Now,
So as have like that. So if let's say I'm looking at 3 defects in a day, and there's this criteria priority, so shouldn't that list it like from like higher to the lower?
Again, this one they've just ordered it by ID. You can order in whichever way you want it, right? You can focus on that. This is just an sample report, right? People look at it from different viewpoints on that, right? Because when you put this, right, the development team, which is focused on working on security versus the database team, they're going to look at it differently, right? They said, I don't care other defects. Tell me what are my database defects, and I'll focus on working on that. It depends on the audience. They're going to look at this report in a different view. Most important aspect, once you identify this defects, it's important to do an impact analysis. What is the impact of that defect? Right? You need to understand it. How long it's going to take it to fix it. Once it's fixed, how many test cases you have to retest it? How much of regression testing you need to do? Okay. What does that do to your other schedule? Right? If I have to retest those things again, that means I'm not testing something else because I have to retest these things. That means my timeline is going to be delayed. If my timeline gets delayed, what is the impact on the business? Or the users who are trying to use the system or who are expecting it to be done. So all of those things get cascaded, and you need to do an impact analysis on it. Okay. A lot of times like this, if you see it, and I think it's Apple did that just 7 or 8 days ago, like they identified a defect. They released a patch. That's not just sufficient, right? Everybody who's using iPhone and iPad has to apply that patch to do that. So impact analysis is significant, not just you, from your user point of view. Well, what does this defect means to? Right? And if you don't fix it, right, that one was essentially a security vulnerability. that actually somebody can take control of your iPad or iPhone through an app and can essentially get all of your data from your phone into it. That's why they just did a overnight patch, and everybody says, if you don't finish this patch by this date, we're gonna lock certain phones. Like a lot of corporations that send it out, you must update everything within 24 hours. Even if it's your personal device, if you're accessing the corporate information, all of those things needs to be in place. That's a huge impact, right? Because everybody now needs to be run test cases, right? The corporation has to say, is every device that is accessing the information is a certain version or not? Or they applied this patch, right? And what is the cost of that to the product? And that determines essentially how you prioritize, right? And the wider the impact is, the criticality is going to be higher for that particular defect. Okay. Any questions?
Is there any software 100% like bug or defect free?
I've not seen it in my 30+ years of software. Now, there are software that they pretend it's defect free because they haven't found a defect. That doesn't mean they're defect free. That's why there is a full-time job. That's why there's so many testers required.
As you say, in the impact analysis I did, when I was doing auditing for Chase, I worked with the Africans, and one day, the impact that you're talking about, I look at the African's work and I pass it. The impact that I saw, it wasn't, it was like just 1 cent different. So when I pass it, you're supposed to be in the court tomorrow. Because I was doing a home lending, and I thought everything was okay, so I passed it. And I came to work and I was addressing a meeting in my office. Okay, what did I do? You passed something like it's not passing, it's not going through. So then she said, we have to go back to the AFIN for them to ratify the amount. It was talking about amount. And so that's our decimal. Instead of, putting the amount correctly, it missed about 2 cents. And I didn't think it was a big gift. Only 2 cents. So
I'll multiply the 2 cents with 50 million transactions that occurs every hour.
What she told me is that you don't want to go to pass it by 2 cents. Because in back Chase, money pass it. So I got another for it, the African, and I got into trouble. So when you talk about the impact analysis, it was a big deal. It wasn't a big deal, but
That's why it's important to do the proper impact analysis, right? Because then you identify, hey, this is critical. You can't pass the system. Even if it's not accurate, right?
Yeah.
You may think it's a 1 cent here or there, it doesn't.
yeah.
But when you do the millions of transactions happens on a daily basis,
Yeah.
every cent is an
It's
important.
important.
No, I was just saying, if you can correct that.
The project.
Oh,
He just moved.
Yeah, let me move that.
yeah.
That's good.
Thank you. Any question online? You understand the defect analysis and the defect management process? Now, this is all theory, right? We're gonna actually execute all of those things in how you would do it on a day-to-day basis, but it's important for you to get grounded in what each one of those means. Terminology. Okay. Any questions? All right. So what I'm gonna do is, I'm gonna spend a little bit time something to say, if somebody gives you a requirement, how are you gonna start thinking around that requirement? Okay. How do you go about from a requirements to defining the different test cases? What do I need to test for in that given requirement? Okay. So let's start with this.
Take a few minute break, 5 minutes.
You want to take a 5-minute break? Everybody good? Continue, want to take a break? What do you want to do? Break? All right, let's take a 5-minute break. It's 11:48. I'll give 7 minutes. Let's start at 11:55. We'll start with that.
You bring the meeting.
Yeah, I'm gonna get one. I'm just getting ready.
Right.
All right. So let's get started. So how do you go about, like, it's taking a requirement and start understanding how many test cases you will need it in order to test that requirement, right? So let's take a basic example first. Any systems, right, that you try to go into it, you need to log in effectively, right? So let's say if I want to, like, it's logging into our flow as a, let's say, as a dealer user, right? How do I know that my login works properly? Right. So let's say if my requirement is, let's see if I can, and say as a user, and let's be more specific, right? As a dealer user, I want to log in into system. So if this is my requirement, that's what I want to do. Okay. So if I have to test this, what are the different things I need to consider? Okay. So think around is the simplest way, right? There are possibilities, right? So I provide, right, a valid user ID and a password, right? If I do that, I should be able to log in fine, right? So that's one, I can do it. Second thing I need to test it is, what if I provide invalid password? Should not be able to log in, right? So I need to test that, right? So I want to do a valid ID and invalid password.
Don't you need a URL first?
This is assuming that I have a URL,
Okay.
right? So the URL goes into my data. If I go into that site, how do I know for sure I can log in or not? Right? There is a third possible combination. I don't have a valid ID, right? I put it in valid ID. Irrespective of whether the password is there or not, system should not allow me to log in, right? As long as I have invalid ID, right? So I provide invalid ID is another thing I need to test it. That hey, if somebody is trying to, like, it's log in with invalid ID, they should not be able to go. Okay. Another variation of this could be is, what if I don't provide any user ID or password and I click into login? Should it allow me? It should not, right? So something like it's called it's no ID and password. Right? Sometimes no data is the other condition that they've got. So if I want to test a dealer user that I want to log into our phone systems, in order to make sure that I allow the dealer user with just only right ID and a password only, I need to make sure I test all these 4 scenarios and make sure I allow them to log in only if they have a valid ID. At that point, I can say for sure, hey, it's going to allow you only if you have valid user ID and password. Right? So this one is known as a positive test case.
Okay.
These 3 are a negative test case. Okay, and I can say it as long as all of this test cases give me as expected results, I can say that my login works. Right? So I took one requirement, generated 4 test cases to do that. Now, if there are 5 different, let's say, user types in my system, like Rflow and Rep, or area manager, or site administrator, right? I need to repeat this for each one of those types to make sure it is expected results for each one, right? Or I can say, irrespective of what user types they are, right? As long as they exist into the system with a valid ID and a password, they should be able to do that. Now, the only tweak would be as an expected results, right? What is my expected result? What should I see it when I log in as a dealer versus when I log in as site administrator versus when I log in as the RFREP? That changes a little bit, right? But the structure for the login remains the same, irrespective of how many, right? So I may have 4 or 5 users, I may have 40 test cases. But more or less, if it's all 40 test cases starts with the same tree, just tweak it a little bit, unexpected results, and I'm good with that. Right? You see how I can do the testing to validate this? Okay, so that's an example. Now let's actually take one from your requirements document and say how you're going to go about it. Okay. So I'm going to pick one from your managing users, right? So here, let me see if I can test it. So this is a requirement, right?
So valid last name and first name.
Right. So what are the scenarios, right? So you say it's a valid,
Last name and first name.
right? So that's just one possible. What are the other scenarios?
What if you have
Valid
multiple,
last name and first name.
what if you have multiple same first and last names?
Okay,
What's the
so
alternate?
hold on to that. Right? So let me just put that. Do you feel this requirement passes 3C and T first? Pretty clear, right? If I have my first name and last name, I should be able to generate it.
Multiple people have.
Right.
same-
So it's not clear to me. What if there are 2 Bob Smith in the system? How does their user ID need to work? Right? So this requirement doesn't pass the 3C and T test because it's not complete. Right? It's correct, but it's not complete. Okay. So what do when you talk to your business users, right? And says, wait a minute, how do you want me to auto generate if there are 2 people with the same first name and last name? Right?
I think I remember.
Okay.
Well,
Don't come up with your requirements. That's the first rule when you go into quality assurance and the testing. You never ever come up with your own requirement. Okay? You got to figure it out. When you go it, what question you have it, and you go back to the user and ask them, hey, in this scenario, how do you want the system to behave? Right? So we'll pretend Herschel is our business user here, since he was involved with writing this document with the client. Herschel, if there are more than one users with the same first name and last name, how do you like to generate their usernames?
Okay, before even I go there, do you know how, let's say there are only one unique first name and last name, how the username would work?
I was going there, but I was going to go there later, but let's start with that.
Because that's the important part.
Right, so here's the first question. Forget about there are two people, right? If there is one Bob Smith, what username you want to generate? You want to generate entire Bob Smith, or you want to generate B Smith, or you want to generate Smith B, or you want to say Bob S? What do you want to generate? Because it's not clear from here what exactly it's going to be generated.
It's not
It's missing
It's
the
not complete,
calculation,
right?
Missing the calculation.
So let's start with that first. How you expected the username to be generated just based on a first name and last name?
Right, so I would expect that to be first letter of the first name and the last name.
Okay, so that's one thing. Now, let's say we have two Bob Smith, right? You can't have two B Smith. So how do you want to handle that scenario?
So it would sequence the second box Smith. So first one would be generated, B Smith, whatever. Second, the new one, second would be incremented by one in the sequential. So there will be some number sequence.
So it will be a B Smith 1 or it will be B Smith 2 at
B
that
Smith
point.
one.
Okay,
It will start with one and then it will go on from the sequence.
anticipate B Smith and then B Smith 1.
Yep.
Okay.
And B Smith two.
All right. Do you feel now it's complete? Or is it still missing?
How about the character, instead of one say this, A is equal to B? Would that also count?
So that again?
I say, how about the character, instead of a number, sequential number?
Again, you're coming up with your requirements. Don't come up with your requirements. Right? That job is business analyst and a business user. Your job is to say, is it correct, complete, and consistent? Okay. Do you feel with this two additional information to that, now it fulfills and the requirement is complete? Or do you still feel that something is missing? You feel that something missing? What is missing?
Then you select 1, 2, 3, 1. And
That's what it's already said, right? Put a sequential number at the end of the username.
Can you use any kind of special characters or anything in between or anything extra?
That's again, you're coming up with your requirement.
Okay.
Based on the three pieces of information which is there, do you feel that you can handle all the scenarios for the username generation? That's the question for you.
That's what the family is. Last name is
What if it's too long or something?
It's a database. In most of the modern database, there's no restriction on the length. Okay, so based on this, now the way you figure it out is, let's just go ahead and use these three rules and see what all test cases we can come up with. If they come up with a situation that requires clarification, then we can go back. Right? So now, based on this thing, what other test scenarios is needed, right? So I'm gonna write it so it's easier to read it. So the first scenario is valid first name plus valid last name. I would not say valid, it's first name plus last name, right? Because you can never know what is first name or what is last name of the person. Right?
How do you divide it? So this is one scenario. Right? The second scenario that we talked about that we need to worry about is identical first name and last name, right? That's another scenario. Third scenario. What if they don't provide first name? You have to test it. Right? If user try to create user ID without providing a first name, right? But
You will
it's
not-
not the scenario for test case, but this scenario, that's.
Why not?
That's when creating.
Go
the-
back to this one, right? Two
No.
fields, one valid, unvalid.
That's for when creating the username.
Right.
User, not when we are testing if it is logging in.
What? So
We log in after we.
So that's another important thing. Do you understand when this requirement comes into the picture? When does it come into picture? Does it come into picture at the time of login?
Is that what it is?
When does this requirement needs to be validated? Not when I'm logged in, because at that point, my user ID is already created.
Before.
When I'm creating a user,
Yeah.
when I'm creating the user first time, that's when my user ID gets generated,
Before the password.
right?
So context is very important.
So it's important when you look at the requirements in a big picture, when that requirement comes into the play. Right? This comes into play when I'm generating a username, not when I'm logging in, because by that time the username is already generated. Right? So the first scenario is I provide the valid first name and last name. That means there is some data in it so that I can use that data to generate the user ID. Second scenario is I already have a user with that name. I'm still providing a Bob Smith. So it should generate B Smith 1 instead of B Smith. Right? So that's the scenario I need to test it. Third scenarios, I need to test it. Is no first name. Right? The next scenario I need to test it is no last name. I also need to test it if there is no first name or last name. Right? Is this sufficient? If I do this many tests, can I generate to fulfill that condition? Or do I need something else?
I think we need the identifiable character, if it's the same, you do the identical name. And you're going to put in the identifiable character like the one. Also, so,
Right, so there is, you have to test it two different scenarios, right? Is this the first time this scenario occurred? Or if I already have a B Smith 1 then I need to validate that generates bsmith 2 and doesn't generate bsmith 1 again. Right? So this is subsequent instance. Right? Anything else that I need to think about? Okay. What we just went through it, right? This is called a tree diagram. So you take a requirement and break into as many branches as you can, right? To the granular, and every branch. Let me see if I can change the color. Right? So every branch that you went through it, it's essentially a test case that you need to write it in order to validate that requirement, right? So in this case, if I have to validate this one requirement, I need to write 6 test cases and make sure all of that gives me an expected result, right? So now this is a valid positive test case. So is this, so is this. These 3 are negative test cases. I have to have all 6 working in order to tell that requirement is working as expected. Okay. Any questions? It's Joyce.
If you say like the first name Latin which would be like capitalized, is that a cosmetic?
That's cosmetic, right? So bsmith, whether I uppercase it or lowercase, is still the same.
Okay. It wouldn't matter.
Right.
Now, the most
But
important
like,
part is.
if it's case sensitive, that's also comes in requirement.
Right, that
Making
should
it-
be a requirement, right?
Okay.
So, Mr. Business Users,
There is no requirement.
there's, the case sensitive doesn't matter,
Okay.
okay? You're saying something, Harshit?
Yeah, the only part I was saying,
One
important part is make sure you understand the context of the
If
requirement.
it's
That's the
like
most
B
important part,
Smith,
okay?
there is another, like, it's another first name with B and the same last name.
So Bob Smith versus Brian Smith,
So
right?
would that come into the subsequent?
That does come into play, right? So how do you want to handle that?
It will just keep on increasing.
Just keep incrementing, right? So that gives you another scenario, right? Which is essentially,
If it's not identical, but same first name,
right? So
same last name with different first.
it's identical first name letter and last name, right? So that becomes another scenario. So now you have 7. Okay. Any other scenarios you guys can think about? All right. So it's a good to get paused here, right? Now let's talk about the requirements or homeworks, right? So the first thing I talked about is reading the test plan document, which is in your folder, read through it,
Requirement.
right? That may force you to read a little bit more again on the requirements. Okay,
That third tab.
the third tab in that document, right? Which is called test plan. Remember what I said, the last 2 pages are the estimation. Maybe walk through it. Also, Herschel will send it out. Some requirements,
Right.
5 of them. What you need to do it is for each one of them, come up with this tree. Okay, if you feel that requirement is incomplete, Okay, note it down, send Herschel an email. Saying, hey, you need a clarification on that requirements when you read that, what should be there? He can give you a clarification. But when we meet on Thursday, we'll talk about any questions you may have it from test plan. And then we will go through your trees. We'll talk through it. Right, just like what we just did it, like the exercise in the last 20 minutes in the class for testing. Okay,
Make sure you guys read the requirements again.
Yeah.
That's the most important
Yep.
part.
important is you need to understand the context. When does this come into play? For defining the test cases. Okay, any questions?
So read to the test plan, that's what you said, right?
Read the test plan. If you have any questions, we'll talk through it on Thursday. And then Herschel is going to send it out. 5 requirements for which you need to draw this type of tree. Okay. And just pick it up, like you can put into the Google Word, Microsoft Word, Microsoft PowerPoint, whatever it is, you can put it like what I did there. You can just make it a tree. The important thing is make it such a way that you are able to share with us during the call on Thursday. And we can talk through it. And everybody can see it, right? The lowest way, you can just write it on a piece of paper, take a picture and send it, and just make sure the picture is visible. Right? But the one way it's easiest is you can do it on this way or the picture, whatever works for you. But he's going to send it out 5 requirements. Build a tree. 5, like this is 1. You will send it 5 like this. He will do the tree. We'll talk through the tree. It's important is to get that leaves, because then in the next class, we're going to take those leaves and you're going to start writing the test cases. Okay. You'll send it out in an email, which 5 1. So you will have clarity on that.
It could be 6, I think.
Yeah.
But make sure you read the requirement, okay, try to understand who is doing the work, when the requirement, when this requirement comes into play. So that's the most important part.
Herschel will send it out this also in an email.
Okay, I don't have too much.
But you can take a screenshot if you wanted, so that you can just get it started for
Yeah. Every requirement is different, so I don't think you can reuse any of these things.
But
The
still
mindset.
the-
The mindset, how you break it down.
Yeah.
Okay. Right. So now you're going to start seeing a shift starting next class. There will be less of talk, it'll be you doing a lot of work of how you work it in the real life when you go to the workplace. Okay, and we'll start with this tree. Okay. Any questions? Sneha, Thomas, any question online?
No, we are good. I'm good.
All right.
Yeah, good.
Fine. So let's just pause it here for the day. And then we'll pick it up on Thursday, reviewing the test plan, any questions you have. And then on next Sunday, we're gonna start diving into writing the test case. Okay? All right,
But we still don't have this, this class also, that we don't send it.
Yes, I'll send out the video as well, so that you have.
I'm gonna pause the recording.
Do we need to read the test